Welcome back to Cosmic Compass. Today we're diving into one of the most daring space missions of our time, NASA's Juno probe at Jupiter. Since 2016, Juno has been orbiting the gas giant, braving deadly radiation and sending back data that is transforming everything we thought we knew about this colossal planet. What has Juno discovered? How has it changed our understanding of Jupiter and even the solar system itself? Let's explore together. On July 5th, 2016, a spacecraft, no larger than a small car, entered the domain of the largest planet in our solar system. Its name was Juno. After a journey of nearly 5 years across interplanetary space, Juno successfully placed itself into a polar orbit around Jupiter. Why did we go to all this effort? What secrets could Jupiter possibly still hold? You might think we already understand the gas giant. After all, it's one of the most visible planets in our night sky. But as we will soon discover, Jupiter is far more mysterious than anyone expected. Let's retrace Juno's daring steps and uncover what it has revealed: storms that defy imagination, atmospheric puzzles, unexpected magnetic forces, and even the possibility of snow falling on a world of raging giants. Juno's mission is unlike any other. Instead of circling Jupiter in a wide equatorial orbit, as previous spacecraft had done, Juno follows a highly elongated path that brings it swooping just 4,200 kilometers above the cloud tops at its closest approach before it swings millions of kilometers away again. Each orbit takes 53 days to complete, allowing the spacecraft to dive in, gather data quickly, and then retreat to safety. Why such a strange orbit? The answer lies in Jupiter's deadly radiation belts. The giant planet traps enormous amounts of charged particles in its magnetic field. Any spacecraft that lingers within these regions is bombarded with radiation strong enough to fry electronics. Galileo, the last dedicated Jupiter orbiter, suffered greatly from this problem, with instruments failing long before their expected lifetimes. But mission planners found a clever loophole. Between Jupiter's upper atmosphere and the inner edge of its radiation belts lies a narrow gap, a cosmic safe zone. Juno exploits this gap by diving through it at incredible speed, collecting data in just a few hours. Remarkably, the actual radiation levels Juno encountered were 10 times lower than predicted, a welcome surprise that has extended the spacecraft's health and mission potential. Every close pass or perish over is a tense moment, but each dive has rewarded us with glimpses of Jupiter more detailed and dramatic than humanity has ever seen. For centuries, we've seen Jupiter as a world dominated by horizontal cloud bands, familiar stripes stretching across its equator, interrupted by the famous Great Red Spot. That view changed forever when Juno delivered the first close-up images of Jupiter's poles. What appeared on screen astonished scientists. Instead of neat bands, the poles revealed swirling chaos, dozens of cyclones tightly packed together in patterns no one had predicted. The South Pole in particular looked like an otherworldly painting, with storms the size of continents locked together in an endless dance. Some scientists admitted that if shown these images without context, they might not have even recognized the planet as Jupiter. These polar views shattered assumptions. For the first time, we realized Jupiter is not just a striped giant, but a dynamic, evolving world with hidden faces we had never glimpsed before. Juno is not simply a camera. One of its most powerful instruments is a microwave radiometer capable of peering deep beneath the cloud tops. Scientists expected to find gases evenly mixed below the visible atmosphere. Instead, Juno revealed something astonishing: towering plumes of ammonia stretching hundreds of kilometers downward. Around Jupiter's equator, a massive pillar of ammonia gas was detected, dropping at least 350 kilometers beneath the clouds, the deepest extent the instrument could measure. Rather than being evenly spread, ammonia seemed to cluster and form enormous structures. This discovery baffled scientists. Why would Jupiter's atmosphere behave so chaotically beneath its smooth upper layers? What forces are creating these plumes clearly? The planet's weather is far more complex than previously imagined. For us, it's a reminder that even the largest planets can still surprise us in the most basic ways. One of Juno's key objectives was to investigate whether Jupiter has a solid core. Many theories suggested a dense rocky heart buried beneath thousands of kilometres of hydrogen and helium, but Juno's gravity measurements painted a very different picture. Instead of a sharp, well-defined core, Jupiter appears to have something far more diffuse, a fuzzy region where heavier elements may be dissolving into surrounding hydrogen. Does Jupiter truly lack a solid core, or did it once have one that gradually eroded over billions of years? This question strikes at the heart of how giant planets form, and it remains one of Juno's most profound mysteries. And then there is the magnetic field. Jupiter's field is the most powerful in the solar system, but Juno found it to be uneven, patchy, and stronger in some places than expected. This irregularity suggests the field is not generated in a neat central dynamo, but may instead arise from the strange behaviour of metallic hydrogen squeezed so tightly it behaves like a metal in layers above the core. These findings force us to rethink the very physics of planetary interiors. Jupiter is not just a scaled-up Earth. It operates by rules all its own. Jupiter's magnetic field creates spectacular aurorae at its poles, dazzling displays of light, invisible to human eyes, but revealed by Juno's infrared aurora mapper. These aurorae are unlike anything on Earth. They blaze with greater power, fueled not only by the solar wind, but also by Jupiter's own moons. Io, the innermost of the Galilean satellites, is covered in active volcanoes that spew sulfur and other materials into space. These particles interact with Jupiter's magnetic field, creating glowing footprints in the aurora moving points of light that trace Io's orbital path. Even more intriguing, Juno observed signs that some of the ions striking Jupiter's atmosphere might come from the planet itself, not just from space. If true, this would be the first evidence of a planet fueling its own aurorae, a process never before seen in the solar system. When we look at these images, it's hard not to feel as though Jupiter itself is alive, breathing energy into its skies. Among Juno's most breathtaking contributions are its time-lapse images during close passes. From these, we watch the spacecraft approach Jupiter's northern hemisphere, sweep past chaotic storms and exit over the south. The level of detail is staggering. Zooming in, we notice tiny white specks scattered across the swirling cloud tops. But these tiny clouds are anything but small. Each one is more than 50 kilometres across. Their shadows reveal they rise higher than the main cloud deck made of water or ammonia ice. This raises an incredible possibility. It may actually be snowing on Jupiter. In the freezing altitudes of its atmosphere, crystals of water and ammonia could fall through turbulent storms, melting or evaporating before ever reaching deeper layers. Snow in a place of giant tempests and crushing gravity, a surreal yet scientifically sound vision. It reminds us that Jupiter is not just a distant giant. It is a living, changing world with weather as real as though unimaginably more violent than our own. After years in orbit, Juno has already revolutionized our view of Jupiter. It has shown us unexpected storms at the poles, deep atmospheric structures, puzzling evidence about the core, a magnetic field full of surprises, and aurorae powered by both moons and perhaps the planet itself. And yet for every question answered, Juno has raised many more. What truly lies at Jupiter's heart? How do its storms sustain themselves for centuries? What other mysteries wait beneath the clouds? As we continue to analyse the data, one truth becomes clear: Jupiter is not a solved puzzle. It is a frontier, one that reminds us how little we still know about the solar system we call home. So as we look at these stunning images and puzzling results, let's remember, exploration is not about final answers, it's about discovery. And thanks to Juno, the story of Jupiter has only just begun. Jupiter remains a world of mysteries, a place of storms larger than Earth, hidden depths we still don't understand, and phenomena no one predicted before Juno's arrival. This mission reminds us that exploration never truly ends. With every discovery, we find new questions waiting just beneath the clouds. If you enjoyed this journey through Jupiter, don't forget to subscribe to Cosmic Compass for more stories from across the universe. Give this video a like to help others discover it, and let us know in the comments what cosmic mystery you'd like to explore next. Until then, let's keep looking up, because the universe always has more to show us.